Guten Tag. This is episode 9, 2026. My name is Clemens. We're talking about CNCF xRegistry, and this is Subscribe. Hi, thank you for tuning in. In this episode, we're going to talk about CNCF xRegistry. CNCF xRegistry is a project that was born out of the CloudEvents project in the CNCF, actually in the Serverless Working Group in the CNCF. And as we were done with CloudEvents, we found that now we have an eventing model. But then as we were looking at documentation of how people were starting to implement CloudEvents, there was always a kind of documentation by example, but no good formal way of documenting them. So we need to have a way to go and say, this is the kind of CloudEvents we're expecting, and have a formal definition, machine-readable definition of sorts. And then also be able to go and describe the payloads of those events, which means we needed to be able to go and refer to some sort of schema, and then have a schema that we can go and use with a data schema attribute that exists in CloudEvents. And then once we have the notion of these event types, groups of event types, then we want to be able to go and also define endpoints. So that was kind of the logic that we say, okay, we need to be able to go and have some way of have the publisher of events define all these things in a formal way. That's how we started with xRegistry. So we started with CloudEvents, and what we already had is CloudEvents that I talked about in the prior episode, so we're not going to spend more time on that. And we had in the CloudEvents project a CloudEvents schema registry. And the CloudEvents schema registry is effectively a registry. You see Event Hub here in the middle, so that we actually implemented that CloudEvents schema registry. We contributed that protocol at Microsoft to the CNCF. And the schema registry has a very simple purpose. A producer produces a message, and they're using Avro or protobuf. And the point of doing so is that you're using any of these binary super compact encodings, is that you can leave the metadata off the wire. So you put the metadata, which means the description of the types and the description of the field names, etc. You put those into an external document, and then you point to that external document. The consumer can then go and resolve that reference, will read that external data, and they can then pull the payload data off the wire, and they only have to go and decode the payload data, but the payload data then can be much, much more compact than the data that you would have, for instance, with JSON, where you are putting all the field names, etc., all on the wire. With protobuf, Avro, those two encodings are ultra compact, but you have to have a schema on the consumer side to understand them. And so we built a schema registry for CloudEvents, in particular, to allow data to be encoded in both the data and the event itself to be encoded in super efficient encoders like protobuf and Avro schema, and then to go and exchange those messages. Now, it'd be nice if we could go and describe then all events kind of a machine readable way, as I just talked about. And so we sat down and kind of thought about how that would look like. And so here, an example on the screen is a set of messages that are related. So there's one producer, the Fabricam.lumen light bulb that is raising a set of events. And then you have at the bottom, you have a set of schemas, and those events, the messages, are then linked to each message definition is then linked to its schema definition. We also needed to have versioning built into this. So we were then starting to think about how that ended up looking. It ended up being a split of the CloudEvents project. So we made it it's still all happening in the serverless working group inside of the CNCF. but it's now a sandbox spec project. The CloudEvents project is graduated, so it's one of the top level projects in the CNCF. And this sandbox project is a generic registry, so it can deal with all kinds of metadata. Because one insight that we had when we were building this was that we had a registry for schemas, and we had a registry for messages, and we had a registry for endpoints. And initially, we were effectively writing one big spec with REST APIs for each of these areas, and we found that there was a very substantial overlap between all of those things. Like pagination would have to be the same, the way how we do puts and gets for various objects would be the same. So we found ourselves kind of in the place where we started with building kind of one registry with kind of 3 types, but then ended up building effectively 3 distinct registries, which could also stand by themselves, because a schema registry could also be useful all by itself. So that's where we started. That's where we landed. We landed in a place where we needed to have a common foundation for these 3 registries, and that's how the name came about of xRegistry, which is the extensible registry. And so we have a extensible core that is then model driven. So we have kind of formalized these 3 starter registries into a model-based system, and we by now have in some other tooling, we have numerous different models that can represent other metadata types. But for the 1.0 release, which is impending, we are focusing on serialization validation schemas, message and event definitions, which then refer to those, and then eventing endpoints, which also then refer to those event definitions. The design principle we applied is that we wanted to make sure that we build a metadata API which works both as an API, so you can build a server, and the server can go and help you by doing things like document validation and also version integrity and compatibility checks. But that we could also go and store an entire registry as a document. So the idea is that you can go and start with a local document that is sitting in the module that you're building alongside the service that is raising the events. And you can then bring that document into an API-based registry, which then can be referred to, for instance, by consumers that need to go and get at schemas, but also by code generation tools, and that can then also be integrated with something like a governance application. So there is an API which can be broadly implemented in all kinds of systems, registries, and governance systems alike. And there's a super simple model which is document based, and the goal was for those models to be completely symmetric. And symmetric means that we have a similar path structure, a similar navigation structure across all of those, which I'm going to get to in a second. So the core specs are the primer. That's a principles and general introduction document, the core specification. Then we have an HTTP binding, which are the HTTP API definitions. That is now a separate spec, because we can imagine that we're also going to do an RPC binding for the core spec in the future. Then we have eventing specification, of course, CloudEvents that can be raised by an xRegistry server when something changes. A pagination spec that explains how we do pagination. And then we have schema documents. We have an open API document, and we have also JSON schema and average schema documents for the core spec. As said, the structural organization, we have always a notion of a group. All the resources are always in groups. There's a group ID, there's a resource type, there's a resource in it, and the resource can then be versioned. So you have a schema group, a set of related schemas. In that is a schema, and that schema has versions. And really those versions are the documents, the individual schema documents you have. So there's a built-in versioning management model, and the built-in versioning management model also has things like ancestry, which means you can go and manage version graphs inside of xRegistry as a matter of the core spec. The built-in model specifications are, as I mentioned already, the schema registry model for any kind of serialization schema that you like. We have explicit support for JSON schema, XML schema, protobuf, and Avro. There's a message registry model for with specific application protocol definitions for AMQP, MQTT, 3.1 and 5, HTTP, Kafka, and NATS, and for a protocol neutral envelope, CloudEvents 1.0. There's an ongoing joke whether we might go and add SOAP as well there. And then an endpoint registry model, which is for communication endpoints, again, for the same protocols. And all of this is extensible. So if you want to go and bring your own protocol, you can. And if you want to, bring your own envelope format, you can. So all of those things are as extensible from a principle as the specification itself, and also as we brought that as a principle in CloudEvents. There is a general schema model that we bring. I'm not going to spend much time in here, but we made a very, very simple schema to allow you to go and create your own model definitions. And then we have a number of tools. There's some project tools that we built. There's a server implementation in Go. That's a full server with all the features that are in the specification. It's a reference implementation. There's a companion CLI tool for the client to go and interact with the server effectively. There's a tool called the xRegistry code generator, another CLI tool, which allows you to go and create code based on these definitions. This is a topic for an entire session in the very near future. And the xRegistry viewer, which is a navigation tool for registry APIs to go and visualize them. So it's a fairly pretty way of navigating a registry interactively. So practically speaking, we're using xRegistry at Microsoft in Microsoft Fabric. So when you create an event schema set, really what's underneath it is already an xRegistry. And when you go and create events, those events are stored as messages inside of message groups, and the associated payload schemas are payload schemas in the event schema set. And so that means that if you are associating a source on the event schema set, we now have the opportunity to know, what events can be handled, and then also which schemas belong to them. That then enables, and that's also what we already do in the platform, is we can go and create a KQL table at the end of the pipeline that has exactly the right properties with the right types for the events that come in on the other side. So building type-safe pipelines is the top motivation for all of this, and we are already doing that inside of Microsoft Fabric. So here's a picture of this. You can go and create inside an event schema set. You can go and add event schemas. Each of them has a payload schema. We're using what we call the Microsoft event data schema for it, which is a superset of Avro, which has a few differences, but generally it's Avro. And the goal is then basically to also allow further kinds of metadata to be represented in xRegistry, and we have some tooling that supports that, which you also will learn about in the very near future on this channel. That's where we can go and take existing registries, existing metadata tools, and just project them out into xRegistry in the xRegistry format and make them all effectively approachable in the same way. So that's what I had for you today, and I hope that was informative, and I will hopefully see you soon.